Hello, welcome to cubics with one x-intercept. We've already had a look at the ways that a cubic could have 3 or 2 x-intercepts. There are 3 circumstances that you would find a cubic that only has one x-intercept. The first circumstance is that if it's presented in the graphical form, which is y equals a outside of x minus h cubed plus k. This is essentially just x take h multiplied by x take h multiplied by x take h, which is the same value for x cubed. Because there is only one value for x in this equation, there is only one x-intercept, even if it's translated or dilated or reflected. The example that I've given here is y equals 3 outside of x take 2 cubed plus 5. If we go ahead and solve, we can find that there is only one x value, and that is positive 0.814 when y equals 0. It's good to remember that a cube root only has one solution, unlike a square root which has 2 solutions. A cube root only has one solution, which is why there can be one x-intercept for a cubic. The second way is if it's in the simple form y equals x cubed. The intercept will be at 0, 0 every single time, because it is the same value for x cubed, and when y equals 0, x equals 0. The third way that our cubic can have only one x-intercept is if it's a linear biquadratic with a quadratic that does not itself have any x-intercepts. So that's our x minus h multiplied by ax squared plus bx plus c. The linear will cross the x-axis once. A quadratic will often cross an x-axis on its own twice, or it may not cross the x-axis at all. If the quadratic by itself does not cross the x-axis at all, that means that as part of a cubic, there will only be one x-intercept. So the example that I've given is x minus 1 multiplied by x squared plus 4x plus 5. The linear part, x minus 1, will cross the x-axis, and it will cross the x-axis at positive 1. The quadratic, however, we need to have a closer look at to see if it has any x-intercepts. So I go ahead and find the square, and I find that the square of that particular quadratic is x plus 2 squared plus 1. There's a heap of information in this formula now that I can take to understand whether or not the quadratic has any x-intercepts. I can see that the a value is positive 1, it's just not written, it's invisible, but that means that the parabola has a positive u-shape because a is a positive number. I can also see that it has a vertex or turning point of negative 2, 1, which I take from my h and k values. Because it's a U-shape and it has a turning point above the x-axis in one of the positive quartiles, I know that this particular parabola has no x-intercepts. Therefore, I know that the cubic will only have one x-intercept. So I'll show you what I mean by graphing it. There it is, x minus 1 multiplied by x squared plus 4x plus 5. We've worked out the square of the quadratic, which is x plus 2 squared plus 1, and we know that by itself it would form a parabola which has no x-intercepts. There it is. It has a turning point of negative 2, 1, and is in the positive u-shape, which is exactly what we predicted. When that is part of a cubic, it means that the only part that contributes an x-intercept is the linear part. So I'll show you if I take that away and we have the quadratic by itself, it looks like that, which is just what we predicted. If the quadratic by itself has 2 x-intercepts, as this one does, it means that as part of a cubic, it will contribute 2 x-intercepts as well, as it does here. So x squared plus 9x plus 10 by itself has 2 x-intercepts. Therefore, as part of a cubic, will contribute 2 x-intercepts. And that's everything you need to know about cubics with one x-intercept.